Okay, so our next speaker is Sabine Dittmann, is professor for the marine biology at Flinders University and an expert on coastal ecosystem ecology. Her current work includes studying the effects of the environmental flows and a flood event on the benthic communities and the food web in the Coorong. So can we please just wait for Sabine to be mic'd up, all ready to go. Can we please give a big round of applause for Sabine Dittmann? Thank you.
Good evening, everybody, and it's always good to be here. And I also acknowledge that we're here on the beautiful land of the Ngarrindjeri and Ngarrindjeri, and it's always a pleasure to be here and also be able to work in the Coorong. And I'm talking to you about the other. So when you're looking at these icon-side scorecards, then there's this fish that we're going to hear about from Jifeng. We've heard about the vegetation and the birds, and then there's this other score for other. So I'm covering the other. And so what is the other? So the other includes components of the fauna, and they are all of these tiny little macroinvertebrates that are living in the sediment in there. And you see a beautiful lot of pictures on there. I get excited about it. Not everybody might share that. Some of you might have been here for the launch a few weeks ago and seen maybe some of them alive. So there's a range of worms, like those whistle worms, different snails and bivalves and little amphipods and insect larvae that we find in the system. And so why are we concerned with them? So why monitor those others in the system? And that is because they play particular ecological roles in it. So they are very, very important for the food. And so they are being eaten, as you see here, by a lot of the shorebirds, the migratory shorebirds. So they're coming here to forage on it. And there's also a whole range of fish that are benthivorous, so they are feeding on these macroinvertebrates. And you see here from Glen Hill, from the fishermen, a couple of fish guts, and they are chock-a-block full with some of those snails and the worms. So they are very crucial parts. So you wouldn't have all of the fish and the birds coming here if they wouldn't have that lot of macroinvertebrates to forage on. They're doing other things in the system, and so you see on the picture up here, this is up on the top the sediment surface that you normally see. When you get a shovel and you're digging into it, then you actually see these burrows going down, and they are done by worms. So there's some worms down here, and in this case here, there's even some of those little crustaceans, those little amphipods. So they are living in the sediment, they are digging in there, and by doing that, they are actually facilitating that there's an airflow going in. So they are providing the irrigation of the sediment. That changes the environment for the microbes. And you're getting very different processes happening in there that can really help to break down some of the excess nutrients that have accumulated over time. So we've shown through some other experiments that they are really useful for bioremediation. So they have got really important ecological functions in the system. And in many parts of the world, they are historically always used as indicators. So the European Water Quality Framework directives and in many other parts of the world, there's a whole lot of indices and approaches people are using based on macroinvertebrate abundances in their coastal seas as indicators for the health of the ecosystems. And so we're doing that here too. And in the entire scheme of the TLM, the macroinvertebrates and also the habitat that they live in, these mudflats, are some of the objectives. And they are tying in with these overarching objectives that Adrienne had pointed out a bit earlier. So the macroinvertebrates are actually ticking every box for the open mouth and also the fish recruitment and the bird habitat. And assessing the habitat, the mudflat conditions itself also ticks the boxes for the open mouth and the bird habitat. There's a whole lot of text here, but I'm going to show you some examples of those targets and how our long-term monitoring has been helping us to evaluate what's going on. Now, the question was also, when did we start doing that? Where and how are we monitoring that? We started in 2004, at that stage not as part of the TLM as yet, but Russell Seaman at the time at DEW and Ramsar manager here, he was keen to understand why in those days already there was a concern about the low shorebird numbers and whether then the food supply and the habitat conditions in the mudflats were okay for them. And I had pretty much just touched down coming from the Northern Hemisphere, where I had been working for decades in a system that looks very much like the Coorong here and had been studying it. So it was just really a good coincidence that I could commence. So the first few years were other funding and then it merged into the TLM. We've got a pretty continuous data series apart from 2014 when there was a gap in funding. We've covered the entire period really. That's from 2004, there was a little bit of water coming out, 2005-06, small barrage release in that entire stretch of millennium drought. And then we've got 2 flood peaks. And at the moment, it's really excited that we can also follow what has been happening after that most recent flood peak, because this flood peak here in 2010-11 came after that drought. And the current flood that we've just had has been happening after more than a decade of continuous flow. So there's a history in the system. And so the recent flood really hit the Coorong at a very different moment in time, and a much better moment in time. And I can show you that the resilience was much better, really, because of that decade of continuous flow compared to the flood that hit after the millennium drought. So how are we going to do that? You need a really good team, and one of my team, Dafina, is at least here. I don't know where she's hiding. But so you need a good team of people who are happy to wander out in the waders and gumboots, and the equipment that we have are a couple of shovels and a Coorong, where the minister, if he's gracious enough, grants us every year the permission to use this little plastic tube as a device to capture aquatic organisms. I'm still waiting, again, 4 months to grant it for this year. And so every year, the same application, every year. Yeah, anyhow. So we're then sieving the samples. We're transporting it in plastic bags, and you see some bivalves and some worms in here. And then if we've got enough energy, then in the evening we're starting to sort them alive in the cabins. But most of the time, when there's so much in it, and increasingly in recent years, we've got to preserve them and then take them to the lab. And so I'm starting off running through some of those things where we've got the targets and what of our long-term patterns are showing, and how it really helps evaluating what's going on in the system. So just for the mudflat habitat as such, critical is really what are the sediment properties. So is it very muddy, is it very coarse, or is it a mix of it, or how does that mix change? Because that really changes how the worms can live in there. And so we're measuring that grain size composition in there, and then you see a composition plot up here, and the target is that it has to be maintained at fine to medium sands, and that's usually what we're meeting. So they are these blue and orange colors that you see up in here, and most of the sites in there in 22 were like that. And for the median grain size here on that long-term plot, where you're evaluating it against a long-term reference. So for the grain size, it's sitting here too. Now the sorting coefficient, which characterizes that mix of the different colors you see here, that has not really met the target. So that's still different, and so that was not met. The other part that we're looking at is how much organic matter is in there. And so that can also come from either missing functional roles. So if there's no macroinvertebrates and they are not doing that bioturbation, then you cannot get accumulation or other sources bringing that in. And so over the years, so this diamond-shaped pattern in there is based on long-term data from our monitoring, and then the recent year there, and this is the data then from December 22. So the red dots, you see that actually in that year, December 22, so the organic matter content in the sediments was higher than before. So that target was not met, and yeah, so there's been really that elevated amount of organic matter in the sediments. So what about these macroinvertebrate numbers? And we're starting off looking at some of the species numbers and diversity aspects. So how many different species are there? And you see already when you look at the scales of these two graphs, and we're differentiating the North and the South Coorong roughly around Panka Point. And so in the North Coorong, there's usually always many more species than in the South Coorong. And then you see again here, during the millennium drought, they were quite low, and then they started to increase a few years after the flood came, and they have been pretty much higher ever since that long-term reference. And in the South Coorong, we have not seen that increase until then the recently higher flows have started to eventuate. So the lower salinity in my case, unlike what you just heard from David, so in the case of the macroinvertebrates, the lower salinities are the beneficial environmental condition for actually getting higher macroinvertebrate numbers in there. So we see higher diversity in there. And so in this case here, so pretty much the numbers have gone up, and on these plots you see a few of those. You've got the years and then the sites from the Murray Mouse down towards the southern end of the Coorong lagoons. And these two sites here, just they weren't part of the monitoring in those years, and in 2014, otherwise white means no, that real zero. We're also interested in how widespread they are. And so another thing I think that's emerging is that we need to look at the entire ecosystem, and we also need to look at the entire icon site. So really for all of our variables that we're measuring, we need to consider from Salt Creek or beyond, all the way up here to Goolwa. And so we need to have that entire perspective in mind. So along that entire gradient, we want to know at how many of those sites are we finding certain species. And we measure that simply by, well, we know we've got 11 monitoring sites there, at how many of these sites are they popping up in our samples. So that we can turn that into an index, and then we can evaluate it. And you can see that in some cases they are at that limit, in some cases they have been down below that, and then they are going up. And there's also a few species that we've never been finding at all of the 11 sites, and that again is because salinity is too high at the southern end and for many years, and they haven't been there. So these targets of occurrence and the area of occupation in the entire system of being at least 60%, they haven't been fully met, but it definitely is getting better. So when you're looking again here at the scheme over all of the years, you see that there's many more dark colors. So we are getting much, much higher and more widespread populations of those macroinvertebrates in the entire system, and that's mainly through their occurrence in the Murray Mouse and North Lagoon. For the actual numbers, they are box plots up here again, and I'm splitting the North and the South Coorong here, because when you look at the scale here and the numbers that are on there, you see that they're several orders of magnitude different. So if I would plot them all on the same scale, then you wouldn't even see anything for the South Coorong at all. We've had some frank language, so you could say that the abundances of macroinvertebrates in the South Coorong are bugger all. There's hardly anything in there in most of the cases, but in the North Coorong, there's a lot to count. Those samples take us time, and so there's a fair chunk in it. And also the index of relative change on the good side actually is indicating that, again, in relation to the long-term average that we're using as a reference, the numbers have really been increasing in both of the systems. So there's really good signs on the macroinvert abundances. On the plot here, because we've been mentioning the two flood events before, so when you look at the years here during the millennium drought, so you see that there's hardly anything. So abundances were really low. And then after that flood in 2010-11 happened, so there's still not much of a change as yet. So it really took then a couple of years for the abundances and all to come back, because the system was already pretty much, and I use David's term there, was already much in dire straits. So that was really quite a long way of recovery. But you see that since then, we've got many more species and higher abundances, not only in the Murray Mouse, but also in the North Lagoon. And what we're currently seeing, because in the Murray Mouse, the flood had a bit of an impact, but we're seeing recovery now within a year. And so that is possible because during this decade of continuous flows, population established in the North Lagoon. And those populations in the North Lagoon are now providing the source for coming back here into the Murray Mouse. And we've also seen them moving into the South Lagoon when salinities were lower. And so that kind of resilience has only been possible through the higher flows that we've been, and continuous flows we've been having. Yeah, so a similar pattern for biomass. For that time reminder there, I might just skip through the biomass, but that's a similar pattern that you see. And then we're also interested in sort of the entire community looking at all of that. And Jason, thank you. So everyone knows how to interpret these MDS plots. So as a reminder, when they are located closer together, they are a lot more similar. And so the entire community of all of those species and their abundances, when you look at it in the North Lagoon here, so in recent years, that's here where they are, where we've had these really higher continuous flow events. So it's similar here, starting to even shift maybe a little bit, but it's all the same community encircled in green, not statistically different. But then in the early days, it was here, and then you've got the height of millennium drought, and then the flood events here. So the current community there in 22 was more similar to those under other conditions. In the South Coorong, it's usually much more erratic in there, but you see that 22 was much more similar to some other years that had flow compared to the other years during the drought that you see on that side. What's driving that? And again, we can do simple plots by just having the count of those macroinvertebrates against salinity, and you see that all of the higher abundances that we're having there are occurring at salinities roughly below 50. And then when you're looking at it in, again, some community perspective, salinity pretty much is the main driver. So we are not getting, like these here are the years in the North Coorong, which have got those high diversities and high abundance and biomass values, which are really good for the fish and the shorebirds in there. So we only get them when we've got these lower salinities in those situations there. And so we've gained over the years of that TLM monitoring that entire understanding of how the system is functioning. And so it's been incredibly crucial for us to put it all together into our conceptual diagrams, as you see there, and also to really know that that continuity of flow is important, again, because that system has got that memory in it. And so that has been something that I've been able to bring into the science advisory committees in there. At times we're doing also intervention monitoring when there's some particular opportunities, like in this case, directing flow more through U Island to get rid of some of the filamentous algal mats that had accumulated there. But for the sake of time, I'm just wrapping up, or coming close to wrapping up with a bit of an outlook. And so how can the overall objectives of the TLM be achieved in the future? And we have seen that, we do need that flow volume that's coming through, and also we need that high flow and then occasional events in there. So that is something that you see in natural systems, water flow systems and most river systems. So that is a really good thing, and having some disturbance and recovery and enhancing the resilience potential is crucial. We do also need to look much more at the water quality, not only at quantity, but also at the quality of the water in there. And we really have to make sure that we are ensuring continuity of the system, so that overall objective, keeping the mouth open, is essential. Challenges are there because the whole of icon site score is really, really tricky. So seeing that intrinsic gradient in there makes it really hard to just come up with a number for the lot. And then we have got that situation that we don't know really the historical reference. So we've only started really in the early 2000s when there was already an issue and concern in the system. So we have got no other historical data in it. So it was really only earlier this year when, late last year, so in our 23-24 monitoring, when we've really seen some of the bivalves and other macroinvertebrates popping up alive in the South Lagoon, that I thought, gee whiz, now it's the first time having this flood coming after this period of high flow that we get a glimpse of what the system might have looked like in the past. Because we know from the shell records that are there that those big bivalves have been occurring there in the past. But we had never, in the 20 years I've been looking there, seen them alive before. So it was only now that we see that. So should we perhaps look at it all and rejig some of our indicators by actually taking our current situation now as the reference, and then looking backwards at it rather than the other way. So it's so what's our reference? Because I think now we are much more closer to what the natural situation was like. And then some of the long-term trends. So the long-term data series here is based on the mudflats that are accessible. In the HCHB, we've looked at the subtidal sediments and mudflats on the peninsula that show some similar patterns, but we still need to bring all of that together to see whether we might need to revisit or extend some of the sites for long-term monitoring. And just some other reflections on it. It's my favorite field trip. It's sort of the couple of days a year that are sacrosanct for me, that I'm always trying to get out with my team to do the field work here, because it's just so so beautiful. So every time that we're down here, it's just absolute bliss, and I'm enjoying every day that I can spend down here in the Coorong. So I feel very much at home here, I have to say, and we really have to appreciate having these long-term data. So if we would have just fractions of these data, we would not understand how the system functions and can respond to any external drivers. Thanks to the TLM team and all of the funding that has made all of this possible. So it's been really stunning to work with you and gaining all of that knowledge and long-term data series. And thanks to all of the people over the 2 decades that have made it possible to get these data. And that's it from me.